Welcome to the Future Homes podcast. My name is Chris Gaze, and this is where we look closely at the ideas, policies and practical challenges shaping how homes are being designed, built and developed in the UK today. We unpack what's changing, why it matters and what it means in practice for developers, consultants, local authorities and the wider supply chain. Our focus this time is grid connections, why this has become a more important issue and how developers can set themselves up for success. Joining me are Nicola Kennedy from E.ON Next, David McDonald from Advanced Electricity Networks and Dan Neasham, part of the team here at the Future Homes Hub. To kick the chat off, I asked David to help explain some network jargon. What is a DNO and how is it different from an iDNO?
iDNOs and DNOs are licensed by Ofgem and they operate and maintain the electricity network. And they typically feed, new housing developments, business parks, industrial and commercial units. And from a DNO and an iDNO, what's the difference? So one is independent. So the DNO operates in a region, the old electricity regions, and they have a geographic space and they actually connect to the bigger network, which is the transmission network. And then normally below that, then you have an iDNO. So 80% of new homes are connected via an iDNO. They can operate anywhere in Great Britain, but they connect up to that DNO area that is in the geographic region. So that's an iDNO and DNO. And then an independent connection provider, and we'll maybe go into this in more detail, is someone who can build networks that iDNOs and DNOs will adopt. Independent connection providers.
So, Nicola, I was wondering if you could tell us a little bit about E.ON Next and what's the difference between that and E.ON and how do you fit into the world of we're discussing today?
I work within the new build transformation team within E.ON Next, which is a relatively new team. We were set up about 18 months ago. Within E.ON Next, we predominantly work on the retail side of the business and work a lot with homeowners. So what do they want when they're moving into the home? How do we make sure that their bills are as low as possible as they move into that particular property? But across E.ON and E.ON Next, we work across that full value chain, supporting housing developers think about energy right at the very outset when they're looking at purchasing land, and then thinking about all of the different technology and infrastructure that needs to go in to make sure that, one, they're going to be able to build as many homes as possible, but also that the homeowners, when they move in, are going to have the cheapest bills possible.
Okay, brilliant. And today we're talking about grid connections. So I'm going to turn to David and then Nicola. It's becoming more of an issue. Why is this becoming more of an issue, this grid connection? What's happened?
The way we're using the grid's changed and the way we live our lives has changed. In the 90s, back when I was growing up, the grid was very basic. If you even think about your home then, really what the grid was supplying was, your cooking, maybe a little bit on lighting, and then, there was nothing really else on top of that, your shower and possibly hot water. Now that grid has completely changed. We have PV on the roof, so that's exporting to the network. We also have now options for, battery chargers and, battery storage in the network as well and on your home. So the network is really having to evolve to adapt to the changing requirements of its customers. It was never originally designed for two-way power flow. So you've kind of went from a centralized system where big massive power stations and it basically fed from power station to home and everything in between. And now we're seeing that as sort of decentralized, where actually some of the generation is coming locally at your home or in the fields next to your home from wind, from solar. And that all has a huge effect of how that grid is actually designed. And that, we're starting to understand how that operates. We've made really good strides in maximizing what's there, but it also requires some more design and reinforcement to the grid.
Brilliant. And Nicola, how are you seeing it impacting in the way that you're doing your business?
So if we think about the electricity network, the electricity system was really not designed for the scale of electrification that is now required. And we're seeing this with new energy vectors such as transport being electrified. We're looking at heating becoming electrified. We also know that historically buildings were passive. Electricity flowed really only in one direction. And historically, developments just asked for capacity from the grid, and that wasn't an issue. One of the things that we've really seen over the last, particularly 15 years with the deployment of renewable generation, is those constraints becoming much more of an issue. And we see that an awful lot more particularly in rural areas. What we're seeing with modern developments is they are fundamentally different. So they are generating electricity, they're storing electricity, and what we're seeing is completely different electrical demand patterns with those new developments. And that creates a completely different issue for housing developers to really think about how they are strategically planning both connections to the network, but then also what technologies can go into a particular house and whether you need to focus solely on building technologies or whether you need to be thinking about community energy assets.
So we've talked about this changing landscape, and there are three players, as I understand it, who developers might be wanting to speak to. We've got the DNOs, the iDNOs, and the independent connection providers. So we've talked about DNOs and iDNOs, but who are the independent connection providers? Dan, do you want to just come in and let us know?
ICPs, independent connection providers, they're the ones who actually bring in the infrastructure and install the infrastructure where it's contestable. So there are elements of the infrastructure that the DNOs, the district network operator, has to carry out, and that concerns connection to the upstream network, so the high voltage network. But when you tap into that network and install the infrastructure that serves the homes and the development, a lot of that work can be carried out by independent connection providers as opposed to the DNO. Yeah, part of that landscape of different providers that developers can engage with.
And you use the expression contestable.
I'll pick up that element. So the non-contestable bit is the bit that the DNO has to do themselves. So non-contestables is like if you're actually extending, like if they have to take an outage to actually extend something that already exists, where you're actually doing the connection to the existing network. So in a simple one, it's just a final joint that has to be done on the low voltage network. But the contestables then is basically all the bit that you need to build that will connect your home or your industrial or commercial unit. So that is all contestable, and that can be delivered by the ICP, the independent connection provider. And the best thing about that is they actually still deliver it to a DNO and iDNO specification called a G81. So we say, these are all the materials that we accept. These are the building standards that we expect. So they build it to that standard. We actually audit it to ensure that we're happy with it before we energize it. So they are a great option in terms of being able to connect the network faster, and iDNOs, we can look at that whole portion and look at what materials we need as well.
If this conversation is highlighting just how quickly the home building landscape is changing, there's one place designed to help you keep pace. The Future Homes Knowledge Centre brings together the latest guidance on how to design and build the next generation of more sustainable homes and communities, all in one place. You'll find practical guides, tools, case studies, and hints and tips covering everything from embodied carbon and BNG to the Future Home Standard, water, and beyond. It's a growing resource designed for home builders and their advisors who need clarity, consistency, and trusted insight. Search Future Homes Knowledge Centre online to start exploring today.
And is it worth mentioning also, iDNOs adopt or can adopt the infrastructure that's installed. ICPs install the infrastructure, or the DNOs. Equally, I think I'm right in saying, David, DNOs can also adopt the infrastructure due to it being delivered to adoptable standards.
And the thing about that, Dan, is actually if the DNO adopts it, they just inherit it back into their big network. In the iDNO world, we actually pay to adopt that network. So we'll make a financial contribution to the ICP or the client, and that actually is called asset value, which actually ultimately becomes a bit of a discount, if you like, of your connection cost. And then we look after that for the next 20, 10, 30, 40 years. We maintain it, we operate it, and we have to perform the same way as the DNO does. So we have to restore your supply within the same timescales. All the regulations still fit for iDNOs that DNOs have to perform to. So there's a commercial gain of using an iDNO for sure, and that last mile connection.
Okay, thanks, David. And could you give us a bit of an idea, David, what sort of constraints are DNOs and iDNOs under at the moment? This podcast is mainly listened to by developers, and I think we've got quite a good understanding of the stresses and strains that developers are going through. But what's the world looking like from your end?
Things have changed in the home, things have changed, industrial electrification of heat and transport. So the network in certain areas is really starting to struggle just because it wasn't designed originally for that. So when I say struggling, there's things that they look at. It's, there's really techy stuff like volt rise and volt drop and fault level and capacity and thermal limits. But basically is how much, if you think of it like a motorway, how much traffic can go down that road, and you're starting to add much more, and then it becomes congested, and then suddenly it has to be managed to a stage. So it's a bit like that. And if you kind of think originally transmission is motorway and like A roads is distribution networks and then B roads maybe is the iDNO, because all that power flow is moving about now, actually nearly everything needs to be motorway. That's maybe slightly extreme, but we have to upgrade those roads to enable that amount of traffic. And it's the same with the electricity network. There's more required, so the network has to be built to a different standard. And we're working through that. And to be fair to the DNOs, we have optimized what's there. We've started to do some smart things, but we get to a point where you actually have to build something new or reinforce something that's already there.
And Nicola, what are you seeing from your perspective?
So I think the really critical thing that we're seeing from developers is just that challenge of grid constraints and how they are starting to impact site viability. So as you are looking at installing a whole host of renewables on the particular site, on the particular buildings, and you're looking at sites, particularly in really rural areas where you've already got constraints on the network, all of a sudden those grid connection costs are, in some cases, proving really challenging to the developers on commercial viability. So it's already starting to impact decision making in terms of land acquisition, but also the prioritization of different sites that developers currently have. We're going to see it start to drive that decision making more and more.
Yeah, and for me in that, Chris, like it's kind of like that grid triangle now, where you've got grid planning and land acquisition. You have to consider all of them. The sooner you consider it up front, then the less disappointed you might be down the line. Or actually, there's still areas of unconstrained capacity out there as well, but it means you maybe have to move somewhere slightly different. And that can work for certain customers, but for other customers, they're obviously constrained because they own a piece of land already, or they've inherited something that where they're going to build their house. So all those things have to be considered, but early engagement is really critical to try and understand that now.
Okay, so that's a great segue into talking about that engagement. So developers should engage early. Who do they engage with, and how do they go about that process? So David, I'll start with you, and then Nicola, I'm sure we'll have something else to talk about how there may be new alternative options. But what's the main way of dealing with this, David, and going forward?
The important thing to consider first is actually the exam question. So what are you connecting? And what are you going to actually connect? So I know Nicola and maybe others like her will feed into that type of process, because ultimately why we've found some of the struggles to date is because we've kind of piecemealed these on later. So somebody has built a house and we've said, oh, that's fine for the house, and we've designed a network for import, and then they say, oh, we want to put 5 kilowatts of PV in the house. Well, maybe the network hasn't been designed for that. And ultimately, when it's one house, that's fine. But then when that scales up, then the network starts to struggle, and it's back to the road analogy again. So actually, the first important engagement is what are you doing, and what is your long-term plan here? And then at that point in time, then engagement with the DNO, iDNO, ICP community is where you want to go next, where you can contact your DNO, your iDNO, or your ICP and say, this is what I want to do. And then the application reflects exactly what's going to be done. And then an engineer can design it.
What's the developer going to connect? And I think, David, also, and when. So if we're talking about large sites here, phasing is really important. What we've often seen as a sector is developers going for a big chunky load at the outset, and the load's actually not going to be there for 2, 5, possibly 10 years on big sites, which really affects network planning upstream. And if that phasing is reflected in the application, often it's a yes where it could have been a no.
Yeah, and it's actually, the other thing with that, Dan, is underestimating is a thing, but overestimating, certainly historically, that would always have been an issue. I don't want to get in trouble with any M&E consultants, but generally the diversity factors that are applied, you kind of just like, oh, we'll take the most we can, or we'll take it that everything's on all the time, but that's not actually how a network will actually operate. So it's really important to get that peak right, and then the export bit is a new thing that we're trying to consider as well. But Nicola's probably the person to help us with that overall.
Before I come to Nicola, though, Dan, can I make that inquiry before I even purchase the land?
Yeah, absolutely. You can engage with network operators, DNOs and iDNOs, or it might be more appropriate to engage with an ICP, depending on the situation, before the land purchase. And certainly with DNOs, they're obliged to treat all inquiries confidentially. So it's really no harm in picking up the phone and trying to engage early.
And the other thing there, Chris, is that the DNOs now and iDNOs are trying to publish as much of that data and make it available. So they've got heat maps online, so you can get a high level view of like, is this limited capacity area? Is it a restricted capacity area? Is it loads of capacity area? So you can use the DNO websites to get just an initial flavour of red, amber, green. Is this site actually going to be viable or not? Or how much trouble will it be to make it viable, I suppose? I mean, ultimately, when engineering, we can build anything, can't we? But it's what cost it's going to be and how long it's going to take. So I think that's a nice way to look at it. The heat map is a good starting point, even.
And Nicola, how can engaging with people like E.ON Next help developers in these sorts of conversations?
At the very outset, having the conversations with us, understanding what you're trying to build, what your objectives are as a developer, what you're trying to achieve from a sustainability perspective is really critical. That then starts to drive what the different solutions are for renewable deployment and meeting Future Home Standard. Having those conversations really early on allow us to really think about what that potential infrastructure could look like. And that's when we can start to really think about, is it that you want to connect in a more traditional way and have renewable generation on each property individually? Or actually, when you're starting to look at a really grid constrained site, is there a completely different solution, such as a microgrid, that would really start to overcome those grid constraints, reduce those grid reinforcement costs, increase that site viability, and provide a completely different way of thinking about the infrastructure on that land?
If I've got more solar panels on, is that making the situation better or worse when it comes to conversations about grid connections, Nicola?
It really depends whether you're looking at solar panels in isolation or whether you are then starting to look at battery storage, whether that is on a particular building within a home or whether that is a community scale asset. It isn't just about one particular technology. And that, I think, is part of the mindset shift that we're trying to go through. We've gone from just thinking about one technology. Now we need to start thinking about energy systems. So we need to be thinking not just about the electricity generation on a particular building, not just about the storage on a building, but actually how you then start to layer up things like the electrification of transport. We need EV chargers, whether that is on a property or whether that is a site level solution, community charging. We also need to be thinking about heat. So all of a sudden, it becomes a much more complex discussion. It becomes a much more complex engineering challenge. But we need to take into account all of those to really understand what a potential solution looks like, and also then the impact on that grid connection.
And so do we see that batteries might be a means of levelling out that load profile?
Yeah, batteries work really effectively at doing that. So we can look at both electricity storage, but then we can also start thinking about things like thermal storage. So the use of other storage technologies is also really important within that conversation.
Yeah, the bit that the battery really helps with is the biggest problem for the grid is like peak generation and low demand. So if you kind of think at solar in particular, let's take a housing site example. If you think about solar in particular, the peak export now is going to be like 2 o'clock in the middle of the day, because the generation's all on. Like once you're in a housing site, all those PV panels will generate. It's not like somebody's out, so it doesn't matter. So that'll be the peak export. And at that point in time, it potentially has got quite low demand. There's not a lot of people at home cooking, charging cars, etc., etc. The battery steps in and does a great job at that stage because it can actually charge at that point in time. And that means none of that export, or certainly a reduced amount, has to go to the grid. And then we can actually design the grid in a more conservative way then, because the export is limited, or the PV is being used by the battery. And then when people come home, from a customer perspective, they can plug their EV car in and they can use the PV that was available at 2 o'clock to charge their car at 7 o'clock at night or whatever time they get home from work.
Okay, can I ask you a really mean question then, Dan? Are there certain circumstances where it may be more cost effective to install batteries than reinforce the grid from the point of view of the developer?
I think I can confidently say yes, although I'd hesitate to do so. There are examples of, large-scale battery storage that have been used to limit the connection requirement made of the grid. If you're able to on-site manage the generation and the battery storage, distributed or centralized, that can help mitigate the ask of the connection and may help in constrained environments. I'm sort of using caveated language.
Oh yeah,
because,
yeah. I think the caveats are well heard, and yes, go and consult
but
a
it's
good
those
engineer on your
solutions-
project.
And it's who pays as well,
Yeah, and David, I guess this is a really fast-moving world. I mean, we're only just starting to get our brains around about what's in the future home standard, which is going to be an awful lot more solar panels for starters. And then thinking about, potentially with those batteries and other things. Are there other things that developers can consider in terms of limiting how much power they're actually going to potentially be exporting, which may make life easier for you?
Yeah, no, totally. There's a number of different things that's out currently in the marketplace, and I have no doubt that there'll be more come on board. There's some very simple things where your inverter itself can limit the export to the grid. So you can set a level, and that'll depend obviously what the grid can accept and export and how much reinforcement's required. So you can set a level on your inverter. So you might have 10 kilowatts on the rooftop. Your inverter might be able to manage that to 5 export, and you might be able to then say, well, actually, if there's grid restrictions, we'll actually set that limit down at 2.5, let's say, just for toxic. So that's like rule number one. Then you can move into smarter stuff like microgrids that Nicola has already mentioned. All that is really evolving now, and you can see that conversation becoming more and more more and more realistic and less R&D type driven. That's easier to manage across tens, hundreds of connections at large scale. Obviously, when you move it into a housing site scenario where there's millions of these types of connections, and actually people who are consumers, not actually generator experts, then there's lots of things that we need to consider and how we make that easy for people. But yes, there's a number of flexible technologies, flexible connections, smart technologies, and they're continuing to develop, and that will impact hugely on what's required in the grid.
Okay, and Nicola, talk us a little bit about how microgrids fits into this space and what sorts of things you're seeing coming down the track.
Well, I'm just going to pick up on what David was saying, because I think there's
please
another really important part to that, which is that home energy optimization. When you're looking at a site, you look at average generation, you look at average demand for each individual property. What home energy optimization allows you to do is really understand what the user is doing in the home, what different areas of demand that they potentially have, and how you can then start to use those much more effectively. So really understanding on an individualized basis what the homeowner is doing, what their behavioral patterns are, and how you can then start to manage that energy much more effectively. It allows us to really start to increase that self-consumption, which is one of the most effective things we should be doing to optimize that energy network.
And that decentralized model works really well, Chris. Like, it actually becomes controllable by the homeowner as opposed to like National Grid having to control 1 million homes. So that if you can decentralize into like smart at the point of connection, that actually is a really good model to utilize going forward for sure.
I think that's a really good place for us to sort of draw to a conclusion. So I'm going to ask you, I like to grant 3 wishes, but I'm a bit mean. I only grant 1 wish per person. What's the one thing that you would like folk to take away from this podcast? And I'll kick off with Dan.
For me, it's quite an easy one. Engage early with network operators, electricity suppliers, and make sure you've got those competent people in place to do so.
Okay, David.
Yeah, I think for me, it is knowing what the question is. What are you building? Actually, so the engagement early is important, but actually knowing what you want, like have that full holistic view of what you're doing and what you're trying to achieve on site. And then we can design a network connection that works for you.
Okay, and Nicola, final word for you.
Well, Dan stole my initial one and David stole my second one. So my answer is going to be come and speak to us early. There are multiple different solutions that you can put in place. Having the conversation earlier on allows us to really think about how those different solutions could help you on a particular site.
Okay, brilliant. Well, thank you very much. I've learned loads. It's a really fast-moving space. It's been absolutely fascinating. Thank you so much to Dan, David and Nicola for joining us today. And goodbye. Thanks for listening to this episode of the Future Homes podcast, and thank you once again to Nicola, David and Dan. If you'd like to explore more of the topics we've discussed today, there is practical advice, news and events on the Future Homes Hub website and on our dedicated knowledge centre. Make sure to follow or subscribe to Future Homes wherever you're listening so you don't miss anything. And if you think of someone who might be interested in the podcast and what we talk about, please let them know about us or share the link. See you next time.